Welcome again, intellectuals. This is Siding Institute. If it's your first time to the channel, please consider subscribing. You also hit the notification button so that you may be updated about the new uploaded videos. In the last lecture, we were talking about several things, which includes the relative atomic mass, the formula mass, how to find the empirical formula, and the molecular formula. We talked about combustion analysis. We also talked about Avogadro's number, the Moore and the quantitative calculations. So if you missed the lecture, I'll share the link in the description section so that you may hold. So in our today's video, we're going to talk about solutions and the molality, solution and predicting precipitates, gas forming reactions, and acid-base neutralization. So first of all, we need to know that solutions are very important in our everyday life. So like let's talk about salts in water, sugar in tea, medicine in your bloodstream, or pollutants in water. So all these are found in form of what? In form of solution. So now, how can we define a solution? So our first part, we're going to talk about solutions. Solutions and molality as our first part. So, what is a solution? A solution, in the first lecture, I defined a solution, so I'm just going to repeat it myself. So a solution is a homogeneous mixture of two or more substances, okay, where one dissolved uniformly into the other. So is a homogeneous this is a homogeneous mixture of two or more substances. Of two or more substances, where one of the substances dissolves in, we say, where one of the substances dissolves uniformly into the other substances. So this is how you can define the term solution. So why am I saying that one of the substances must dissolve into the other mixture, into the other substances? Because a solution, like, let me try to talk also about homogeneous. It is homogeneous because the substances in this mixture, they combine completely, they uniformly combine, like you can't differentiate between the two. Let's say, for example, we have a mixture of salt and water. Once you mix these two, you can't see salt in the solution. It will be it will dissolve completely. So these substances will dissolve into these substances. So this now even calls us to talk about two parts of a solution, which is solute plus solvent. So a solution is made of these two things. So a solute is a substance which dissolves in what? In the other mixture. In the other substance which we are calling a solvent. So a solvent is a substance on through which a solute dissolves. Example is this a very common example. So since salt dissolves in water, making this solution, salt becomes what? A solute, and water, it is what? It is called a solvent. This is how simple you can what? You can understand that. Now, what if a question may be, what if oil plus water? Is this a solution? Actually, no. Reason being that these two can't combine completely. You can see a layer of cooking oil what? Floats what? On top of water, you can see. So this kind of a solution doesn't mix completely. So it is a mixture which doesn't mix completely. So it's not a solution. A solution must what? It must uniformly what? Mix. That's differentiate between what? Homogeneous and heterogeneous mixture, which we talked about in lecture 1. So other examples being salt in water, it's a mixture. Sugar in water, it's a mixture. So let's go now. We talk about properties of a solution. How can we know that, or how a solution behaves? What other things can we know about a solution? This is what we are going to talk about now. We talk about the properties of solutions. So a solution is clear and transparent. So the other thing, a solution do not settle. I'm going to explain this. Another thing, a solution is stable. So what do I mean by saying a solution is clear and transparent is that even if colored, let's say for example copper sulfate. We talk about copper sulfate. We know this is a colored mixture. So even if colored copper sulfate solution scatters, it what? The solution don't scatter light. Okay, it is always clear. It will be clear. The color will remain what? The same color. Now, what do you mean by saying that solutions do not settle? This means that solute particles will always what? Stay in motion due to what? To kinetic energy. So a mixture of solute and solvents. These solutes, these solute particles are moved. They move in the solution due to kinetic energy. They don't settle. Like you can't find like a solution of salts and water. You find salt is down, is it at the bottom. Let's say for example, here is a mixture, and you find that water on top and salt particles are what? Are at the bottom. This can't happen because these solute particles are always in motion. They will be moving what? All the surface of what? They are, in fact, they will be evenly what? Distributed throughout the solution. So, what I meant by saying solutions are stable is that this kind of solution do not what? The substances in a solution do not separate. Okay, like you can leave the salt solution, for example, you can leave a salt solution for days. You won't find salts separate and water separate. It will always what? Be stable. It can't separate. So let's now talk about electrolytes. You need to know this also. So what we know is that we are from talking about solutes dissolving what in a solvent, but we should know that not all solutes behave the same. Some they break into ions. Okay, so when solutes break into ions, once this break into ions, are called what? Electrolytes. These are electrolytes. So now, what we need to know is that there are types of electrolytes. Some are strong electrolytes. Some are weak, and other are non-electrolyte. So this is strong electrolyte. They fully dissociate. They fully ionize. They fully dissociate or completely dissociate into ions. Then this, they only partially weak, they only partially ionize. This, they doesn't dissociate. They doesn't dissociate into ions. An example I can give is on strong electrolyte we have sodium chloride. So sodium chloride dissociates into sodium ion and chloride ion. Very simple. A weak acid, we can talk of vinegar. So vinegar, can talk of this. It's a common ion of ethanoic acid. It says, so this doesn't dissociate completely. It doesn't dissociate completely. They partially ionize. They don't form ions completely. So sometimes they may dissociate in form of this. Also hydrogen, but the ions are not fully formed. This is what we mean by weak electrolytes. What about non-electrolytes? This kind of solutes, they actually don't dissociate at all. Example, it's sugar and ethanol. So by any chemical means, you can't make these two, for example, to dissociate and are called non-electrolytes. So let's move on now. So now, since we understand what a solution is, let's go ahead and talk about molality. So molality tells us how now strong the solution we are discussing about is. So it's going to tell us how strong, like for example, how sweet the cup of tea is. That's what about molality. So now molality is denoted by the capital letter M, and we can define it now. For you who may like to know the definition, though you can't be asked to define what molality is at your level, or what you be assessed about quantitative calculations, and on how you can prepare some sorts. So let's now talk about the definition. So it can be defined as the number of moles of solute per liter of a solution. The number the number of moles of a solute per liter over solution. So I was talking about salts as an example. Salt and water, we can use salt to be sodium chloride, which is common salt, plus water. So how much of this, let me now give plus hydrochloric acid, for example. So how much this solute, because we know that no, let me give it water to make a good solution. Yeah. So how many moles, how many number of moles are in this kind of a solution of sodium chloride and water? How many moles of sodium chloride in this in 1 liter? But what we need to know is in 1 liter we are measuring the number of moles in 1 liter of what? Of a solution. And this is what we are calling to be what? Molarity. So molarity is given by the formula M is equal to number of moles over volume, where M denotes molarity, N its number of moles, and V is just liters of what? Of volume. Volume in liters. That's all you need to understand about what molarity. So a question you may receive in an exam. This is also in your lecture slides. Let's do an example question. So the question reads, how would you prepare 250 ml of 0.1 moles of copper 2 sulfate solution? So when you are asked to find or to explain how you can prepare any kind of a solution in that manner, you have been given the volume, you have been given the molarity. So what they are just asking you is to find what? The mass of that, of the compound which has what? Has been asked to find, or the solution. So our first step, I would like to drive the formula. We know that molarity is given by number of moles over volume. Okay, but we are asked to find what? Our aim is to find mass. So we are going to make N the subject of the formula. So once we make N the subject of the formula, we're going to multiply like this. We're going to have N times V. But we know that number of moles is given by mass over molar mass. Okay, because in the question we haven't been given the number of moles, so we are going to replace where there is N by mass over molar mass. So very simple, we say mass over molar mass to be equal to M times V. What do we do next now? We also now make M the subject of the formula because it's the one we are looking for. We cross multiply. We say M times 1, it's M. Then this times everything, I'm going to have M times V times the molar mass. Now that we have everything, what we do next is just to replace the required the required quantities. So let's talk about volume. Volume, we said that this is volume in liters, but we have been given in what? In milliliters. So we are going to convert. So volume would be 250 divided by 1000, so that we may convert to liters, where we are going to have 0.25 and 0 liters. Now that we have all the quantities in their standard units, we can just replace them in the in the formula. So the molarity is 0.1, the volume 0.250, and the molar mass has been given. So if we were not given, you also need to find the molar mass. I explained in the previous lecture how to find the molar mass, so no one can find difficulties to find that. So what you do now is just to multiply by 249.7. When you punch this on your calculator, mine is giving me 62.43 grams. So this is what we wanted. Now we can give a simple explanation on how you can prepare. You just say that dissolve. So what we need is to find this, and you add a simple statement. You say dissolve 62.43 grams of copper 2 sulfate, in water. And make up the volume of, or I can just say in 250 ml of what? Same. All these are what we have just been given, and this is the one which we are from calculating. So this is how simple you can you can apply molarity in preparation of of salts. So it is a very important part, and I'm sure you are understanding. And this question is very important because you are going to meet it in your exam. So if you find this video helpful, please consider subscribing. You like the video, you give it a thumb up. You also hit the notification button so that you may not miss out other videos which I will be uploading. So let's go ahead and talk about other stuff. So now that we know what a solution is and how to measure how much solute is inside it, let's try to ask one question. Can heavy salt dissolve in a solvent? Or what can happen if some of the solute doesn't dissolve? So this brings us now to a very important concept on solubility, which helps us predict whether something will stay dissolved or come out as a solid. So our part 2 now, we are going to talk about solubility, and predicting precipitates. So in this part we are going to talk about now what solubility is. Let's try to understand what the term solubility means. So solubility is the ability of a substance to dissolve in a solvent to form a solution. So we can define as the ability of a solute to dissolve in a solvent. So, but what we need to know is that not all substances can dissolve completely, as I was saying, and some may dissolve completely, other partially, other can't at all dissolve to make a solution. So we need to know about this kind of of solutions. So a soluble solution, terms you need to know. A soluble substance is the one that dissolve completely. For example, salt in water. Salt in water dissolves completely. What about an insoluble? An insoluble substance, it's the one now that doesn't dissolve. Okay, this doesn't dissolve. An example is sand in water. No matter how much you can try to mix this, sand can't dissolve in water. The other thing you need to know is a partially soluble substance. These partially soluble substances are this kind of solutes that can they can partially they can dissolve a little. Okay, for example, we may talk of chalk. We can talk of calcium carbonate, which is commonly known as chalk. So chalk in water can dissolve partially, but it can't dissolve to the fullest. It can't completely dissolve. So it is a partially soluble substance. What about immiscible? You need also to know what an immiscible is. What about an immiscible? So immiscible liquids, these are two liquids that can't mix. They don't completely mix. I gave an example of oil and water. These two can't mix by any chemical means. You find that water will be seen, oil will be seen on top of water. These things are very practical. So you need to be trying it even when you are home, when you are cooking, so that you may know how chemistry is very applicable in our everyday life. So what we need to know is that solubility depends on the nature of both solute and solvent. So let me try to give an example. So this is an example now. The question reads, which of the following is soluble in water? A, sodium chloride. B, lead chloride. So the question has been given. You need to tell between the two. Can this dissolve in water, or can this dissolve in water? How can you predict if sodium chloride can dissolve in water? It's not something you need to guess. Okay, so we can't answer this question not until we learn what solubility laws. So this now is telling us to go and learn about solubility laws. So these laws are going to help us predict whether a compound will dissolve or form a solid when mixed in water. So we are going to break down the major ones, which you are going even to find from your lecture slide. So let's talk about solubility laws. I'm sure after you know solubility laws, you'll be able to answer now the example. So what you need to know, I'll clarify this. First, we are going to talk about always soluble. Compound which are always soluble. So all compounds made from group 1 elements. All group 1 elements, so-called alkali metals. So you go on group 1. When you see any compound from group 1, any compound is made of an element from group 1. That compound must be what? Must be always be what? Be soluble in water. So compound like sodium, you find sodium ion is participating, lithium is participating, potassium, and so on, as long as it's coming from what? From group 1. You need to know that that salt is what? That compound will be what? Soluble in water. So from this we can even tell that this sodium chloride will what? Will dissolve in water, because whole group 1 elements dissolve what? In water. What other which always dissolve in water? Whole ammonium ions. Or ammonium ions. So when you see any compound made of ammonium ion is participating, just know that the compound will always be be soluble in water. So any compound you see like ammonium sulfate, ammonium chloride, any compound, just know that that compound is is soluble in water. Other compounds, you need to know that they are always soluble in water. You need to know that whole nitrates, like be it sodium nitrate, potassium nitrate, all nitrates will always be soluble in water. Chlorates, always soluble in water. You should also know about all acetate salts. All acetate salts, they also dissolve in water. So you see all this, just know that that compound is is soluble in water, without even wasting your time thinking too much. This question you find it more especially in both parts, section A and section B. Expect these questions from your test 1. Very important. So you need to know all the solubility rules. What about those that are soluble? So here I was saying always soluble. What about them that are soluble? Soluble, but with exceptions. So they are soluble but with some exceptions. For example, A, this rule number 1, all chlorides, all chlorine, you say bromide ion, iodide, actually all group 1 are also all group 8 are soluble in water, but with exceptions of this. I'm going to explain this. You need to master this. With the exception of lead, silver, and mercury. This. So when you see sodium chloride only if it is like lead chloride. So when you see like lead chloride, lead chloride is what? Is insoluble. But we know that all chlorides are soluble. But when it is with lead, it is what? Insoluble. So this one is what? Insoluble. You even answer this question. That's why I said that you can't answer this question without knowing solubility rules. So all chlorides are soluble only with these three exceptions. You need to know this. What else do you need to know? Let's talk about sulfates. So all sulfates also are all soluble, except with lead also. With lead, barium, and strontium. So all these So all these, when you see all these are what? All sulfates are soluble, only with an exception of lead, barium, and strontium ion. So you need to know that if a compound is barium sulfate, just know that this compound is insoluble. So with only this expression, with only this exception, the rest are what? Are soluble. What about those that are always? They are always insoluble, but they are also with some exceptions. 3 are insoluble with exception also. With exception. So let's talk of O hydroxide and oxides ion. So O hydroxide and oxide ion are insoluble. They are insoluble except with group 1, ammonium, and what? Nitrate, because we know that these are always what? Are always soluble. Very simple. So if you find like barium hydroxide, all these are going to be what? To be insoluble, only with exception of these parts, which are always what? Are always soluble. Because even if this one is always soluble, but it can't defeat this, because these are always what? Are always soluble. So these are always insoluble, with exceptions of group 1 elements, ammonium ions and nitrate ions, chlorate and acetate ions. The other thing you need to know is about phosphates. Let's talk about carbonate. Carbonate ion, we talk of phosphate ion, we talk of sulfate ion and sulfide ion. So these also are always what? Are always insoluble. Okay, these are always insoluble, but with an exception of what? With an exception of this. Very simple. You need to know this, with an exception of this, because these are always soluble. Oh, yes, I forgotten something on this. Apart from group 1 elements and ammonium ions, and also all these ions here, this also may be soluble with let me say group 1. I said this ammonium ions, also with what? With calcium ion, barium. So all these when happen to be together with the hydroxide and oxide ion, they are going to be what? To be soluble. Minus all this, the rest will be what? Insoluble. This is how simple now you can what? You can understand this. So let's now try to talk about example 2. The question you will find in exams. Let's talk about this example. You are asked to predict the solubility of the following sets. I mean salts. So predict the solubility of the following in order. First, we have been given lead, chloride. Actually, we talked about this. We answered already. We talk about ammonium sulfates. C, magnesium phosphates. Forgotten to talk about phosphate. Okay, it's fine. We're going to talk about this. Magnesium phosphates. Then J, we talk about lithium what? Lithium phosphate. Like this. So this one we talked about, we confirmed to say leads or chlorides. We know that all chlorides are what? Are soluble, but when it happens to found with lead, the compound is going to be what? To be insoluble. So this is insoluble. What about ammonium sulfate? We don't even to start thinking too much because whole ammonium are what? Are soluble. What about magnesium? Magnesium phosphate. So we know that magnesium or phosphate, I've forgotten to talk about. In fact, I mentioned here. Very simple. I mentioned about phosphates. So all phosphates also are also what? Insoluble. Did I talk about this? Yeah, I talked about this also. If I didn't talk about, I said whole carbonates, phosphates, sulfates are what? Are whole insoluble except with group 1 and ammonium. Except with group 1 and ammonium what? Ions. So this one is going to be what? To be insoluble. Because we know that magnesium, it's neither in group 1 nor it being an ammonium ion. So what about this? Phosphate insoluble, we know that. But lithium is in group 1. It is going to be always soluble. This question, you shouldn't even fail to answer this question. When you find it, it's very simple. Just know all the all the rules of solubility. So let's now go on and talk about precipitation. So now that we know that some salts are soluble while others are insoluble in water, so we need to ask that question, like, what happens when we mix two solutions, and if one of the product is found to be what? To be insoluble, what really happens? So it is very simple. What is formed is a solid, and that solid is what we are calling to be what? A precipitate. I'm saying this. We had a soluble solution plus a soluble solution. Two soluble solutions are mixed. What we are going to produce at the end is find an insoluble and a soluble salt, a soluble solution. So this salt is what we are referring to be a precipitate. So precipitation is defined as a double displacement reaction where an insoluble solid forms when two aqueous solutions are mixed. Very simple. When we mix two soluble solutions, forming an insoluble solution is what we are going to be to be a precipitation reaction. So what we need to know, this part will remain dissolved in the mixture, and this one will evolve as a soluble one. Another thing you need to know about precipitation reaction is that this is a double displacement reaction. So a double displacement reaction is in this general equation. You need to know this general equation. So if we mix solution AB, which is a soluble aqueous, and solution CD, which is also an aqueous, we are going to produce AD, which is going to be a solid, plus BC, which will remain dissolved in the solution. This is the general equation. So we know that A and B are two soluble ionic compounds. AD is a precipitate, like I've explained. So how do we now how can we predict the precipitation reaction? Okay, so I can give you some steps which are very important. So how can we predict a precipitation reaction? How can we undergo it? So what we do, we are going to write both reactant as ionic compound. This the way I'm showing you is the way the lecture slide is lecture slide notes are. And I said earlier, some lecturers are very strict. You answer from what you think it is right. Him or her will mark you wrong because he wants the way you are being taught. So the first thing, you need to write down both reactants. You write down both reactants. Now are going to be written as ionic formulas. Number 2, you are going to swap the cation ions. I'm going to show you that. You swap the cation ions. The reason we are going to swap the cation ions is to form the products. These two new products here. Number 3, now you check the solubility loop. You check the solubility loop. We've already learned about solubility loop. The reason you are going to check the solubility loop is to try to check if precipitation occurred. Do we have a precipitate in the products? By using this solubility loop, by using this solubility loop, we are going to know if a precipitate formed if we have a solid a solid product. So if you are going to find that a solubility has formed, then we are going to say that a precipitation reaction did take place. If not, then it didn't occur. So let me try to give you an example. Let's try to give an example. A question being, So a question is, what happens when we mix silver nitrate and let me use what, potassium chloride? What happens? All these are what? All these are soluble solution. These are two solutions. They are mixed together. So what are going to happen? So our first step, is to what? Is to identify the ions. Okay. So in silver nitrate, we say in silver nitrate we have silver ion and nitrate ion. What about in potassium chloride? We have potassium ion and chloride ion. Very simple. Now what we do, we are going to swap. Okay, when you see this, the general formula was like AB plus CD. This was going with this. That's what I'm saying. We swap cut ions to find what the product. So we are going to have the results will be now, this is going with this to produce what? Silver chloride. Okay, so let me write from here. So we are having silver chloride plus what else now? This is going with this because we are having B and C. So I have AD plus B and C. So this now we are having now potassium what? Nitrate. Potassium nitrate. So you need to make sure also that the equation is balanced, and I'm very much sure that this equation is what? Is balanced. So now let's now use solubility rules to determine which of the two products is what? Is insoluble and which one is what? Is soluble. Let's talk about this one. What we know is that all chloride ions are what? Are soluble. Okay? All chloride ions are soluble, but with an exception. I gave an exception of lead. Also silver, like this. So this one is going to be our insoluble solution. And here, since we just have a group 1, all group 1 compounds are what? Are soluble. This is how you can predict. So you are going to say that since we have a soluble, I mean an insoluble and a soluble product, then precipitation what? Took place. This is how simple you can handle a question on what? Precipitation. So let's go ahead and talk about types of equation for precipitations. Say types of equations for precipitation. So in chemistry, chemical reaction are expressed at 3 levels. Okay, and the first one is the molecular equation, ionic equation, and what? And a net ionic equation. A molecular equation, So, a molecular equation, this is just an equation which shows all compounds as they were what? As they were molecules. So, an example, I'm going to give the same what? The same equation we were talking about. We say silver nitrate. Silver nitrate plus potassium chloride. We were having silver chloride as a solid, and we are having also potassium nitrate, which is what? A soluble. So this kind of an equation is what we are calling what? A molecular equation. And you are doing this in grade 10 to write a molecular equation. It's what? It's very simple. You can't even be asked to write here. Now, the question which you may be asked is, it's level 2 of at which what an equation can be expressed. And this is what? An ionic equation. So ionic equation now is going to break strong electrolytes into what? Into ions. Okay? Those are compounds that can what? That can dissociate completely into ions are going to be what? To be broken down into ions. And this is what we call what? An ionic what? Equation. So to write an ionic equation, we only break down compound which are in aqueous solutions. Compound which are in aqueous solution. If there is something like a solid, liquid, or gas, we don't break down. So here, how do we write this? We know that the ions which are here, the ions, we have silver ion in aqueous, ammonium ion also in aqueous. What about copper chloride? We know that potassium chloride, Potassium is a group 1. Maybe somebody may not understand in positive and negative. I haven't explained about this. I know you know because these are cut ions. They are ions of metals. These are non-metals. So that's why we're having a negative because they have to gain what? An electron for them to be stable. We understand that. What about potassium chloride? We say it is also in aqueous, so we're going to write like this. Then chloride ion in aqueous, very simple. Let's come and talk about this now. We know that this is in solid. We only break down those that are in aqueous. So this one will remain like this as a solid. What about this part? It is in aqueous, so we are going to have potassium and the ammonium. Nitrate, I'm sorry. Like this. So this is how you write what? An ionic compound. Now, all this were simple. What if we were to write like what am I going to say? Like calcium chloride. Calcium chloride. How can we write down this? Okay, we are going to say calcium will break down into this. Then, since we have a 2 here, we are going to put it in front. Then we say chlorine. This is the other part which I want you to know. Now, since this equation is direct, no need to use that. So, the other part is the net ionic equation. the net ionic equation. So in an exam, you only be asked to write the ionic equation between the reaction of silver nitrate and what? Potassium chloride. They even end there. So what you need, you yourself, is just to write the what? To complete the equation, you balance it, you write an ionic equation, then you finally what? Write a net ionic equation. So a net ionic equation is found by cancelling out ions that don't change. In fact, those ions that don't participate in the reaction are actually called to be spectator ions. So those ions that you find on both sides of the equation, you need to cancel them. The ones that are going to remain are the ones that participate in forming what? A precipitate. So when you look about this, this is also here. We cancel it out. Potassium ion and potassium ion will go. So what will remain with? We remain with silver ion plus chloride ion. Then also silver what? Chloride. So this is just telling us this precipitate was only formed by these two, and you can even see that they are even alike. This is what we call a net ionic equation. So this is how simple you need to know about these things. So let's go on and talk about let's now talk about gas forming reaction. So a gas forming reaction is also a double displacement in which one of the products is a gas. So this also kind of a reaction follows the same form of precipitation reaction. Let's say AB plus CD produces AD plus BC. But what happens is that one of the products here which will be produced will be unstable. So unstable products will be produced such that it will be what? It will be broken down into what? Into gases. So this kind of reaction produces a salt, unstable acid mainly. It may be unstable acid or unstable base, which later what? Which later disintegrates into what? Into gases. So our example or common gas forming ion types are let's say when carbonates react with acids, what happens? So when carbonates react with acids, they form salts. A salt is formed plus what? Plus unstable acid. Okay. Unstable acid, and this acid now, it is the one which is going what? To be broken down into carbon dioxide and water. Another reaction which forms the gases, which we are calling a gas forming reaction, is the reaction between bicarbonates and acids. So bicarbonates and acids also produces a salt plus unstable acid. This unstable acid is mainly carbonic acid. So now this acid is going is going to be broken down because it is unstable. It can't settle for so long, so it's going to be break down into into carbon dioxide and water or vapor. What about the reaction between sulfides and acids? What happened? This is also simple. A salt is produced plus unstable acid. This kind of an acid is mainly sulfuric acid. Is produced. Now this kind of an acid is going to be break down also into gases, which is sulfur dioxide and water. Very simple. I'm going to understand this when we do examples. What about ammonium? When ammonium compounds, actually ammonium compound or ammonium compounds, when they react with acids or they react with bases, so they react with bases, they produce salts and unstable base. They are going to produce unstable base. Mainly, it's ammonium hydroxide which is produced. So now this ammonium hydroxide is going to be broken down into what? Into gases. Mainly ammonia gas and what? And water. So you need to know all this kind of reaction under gas forming reaction, because you may be given an equation and you ask to complete it, and you also write the net ionic equation. Now if you don't know the products which are produced after a certain reaction reacts with a certain acid or a base, it will be difficult for you to answer that question correct. So let's try to do an example. So let's do an example. So an example is what happens when calcium. What happens? So what happens when calcium carbonate reacts with the hydrochloric acids? So we know that what we were talking about, you already know that carbonates plus acid, because hydrochloric acid is an acid. So when carbonates react with the acids, they produce what? They produce a salt plus what? Plus a carbonic acid, which is unstable. Carbonic acid. So our reaction is going to be our reaction, is going to be calcium. We say calcium carbonate plus hydrochloric acid. It's going to produce what? Under double displacement, we were saying that this will go with this one to produce a salt. We are going to have calcium chloride plus a carbonic acid is going to be produced, which is unstable, because this one is going now with this to produce a carbonic acid. So to balance this equation, what we do, calcium we have 1, even here we have 1, carbon 1, oxygen 3. So it's here where we need what? To put a 2 to balance what? Everything. Now what we know is that this carbonic acid is unstable. So it is going to be break down into what? Into carbon dioxide and water. So our reaction is going to be what? Calcium carbonate, which is a solid, plus hydrochloric acid, which is in aqueous solution. They are going to produce calcium chloride, which is a salt in aqueous, plus this one will produce carbon dioxide, which is our gas, and water. Very simple. So this is all about what? About what we are calling to be gas forming reaction. A reaction which is what? Producing a gas at the end. So now if you've been asked to write the the ionic equation, the net ionic equation, what you do, you're going to separate compound with what? In aqueous solution. So calcium carbonate, it is in solid state, so it will be left like this. It's a calcium carbonate, but this hydrochloric acid is in aqueous, and we have 2H. This is positive, then 2 chlorine, which is what? Which is negative. Calcium chloride is in what? Is in aqueous, so it's calcium chloride. And chlorine, we have 2 atoms of chlorine, producing carbon dioxide as a gas and water. So now we just cancel out ions which we are not participating in the reaction, which we are calling to be spectator ions. So when you see chlorine ion is not participating, and it's the only one which is what? Not participating. So the rest is our what? Our net ionic equation. So this is what now you need to know about what? About gas forming reactions. Let's now do another example. We're going to do two examples. Now what will happen if sodium bicarbonate. If sodium bicarbonate reacts with it reacts with hydrogen bromide, what happens? This is hydrogen bromide. What is going to happen? What we know is that bicarbonates plus acids produce salts and unstable acid. So we are going to write the equation. We say let me finish it here. So what is going to be produced here? We are going to have sodium bromide, because this is a double displacement. We say sodium bromide in aqueous. Also what? We are now going also to have a carbonic acid, because an acid which is produced as an unstable acid. What we know next is that this kind of an acid which is produced is what is unstable. So it will be broken down into what? Carbon dioxide and what? So sodium bicarbonate plus hydrogen bromide after sodium bicarbonate is going to produce what? This kind of a salt. Plus now this one is going to be broken down into what? Carbon dioxide and water. Very simple. So if you ask to write the net ionic equation, you follow the same steps. Let's do example 3. What will happen if ammonium chloride? What will happen if ammonium chloride react with sodium hydroxide? So what is going to be formed? So by now you know that all ammonium compounds, we say all ammonium compounds plus bases. I explained this. They are going to produce a salt and an unstable base. This is the first thing. So what is going to happen is this is a double displacement, so we are going to have a salt, sodium chloride. So first we are going to have this should go with the last here. So we are having our first thing, we are having ammonium hydroxide as our unstable base, then sodium hydroxide as our salt. So now this is unstable. It is going what? It is going to be broken down into what? Into ammonia gas and water. So your equation now will be ammonium chloride, which is an aqueous. It is soluble. Then sodium hydroxide, also soluble. We are having now sodium chloride. Sodium chloride is also in aqueous. Then we had, this one has been broken down into ammonia gas, and water. So this is how simple about what gas forming reaction. So what you need to know is just to know those types of reaction and the products which are formed and the kind of unstable base or gas which is what formed. So our last part, the last but not the least, is we are going to talk about acid-base neutralization reaction. So an acid-base reaction, this is a reaction, or a neutralization reaction is a reaction between a base and an acid, and this kind of a reaction produces salt and water. This is what you need to know about this kind of a reaction. So now, what is an acid? We are just talking about an acid. So this is a kind of a substance. It's a substance which releases hydroxide ion. What about a base? A base releases what? It releases what? It releases hydroxide ion. So these bases and acids, some are weak, some are what? Are strong. So weak acids, I'll talk about this in general. So let me talk about weak and strong acids in the first place. So weak acids, they partially what? They partially ionize. Okay? Ionization is the process of forming what? Ions. So these weak acids, they partially ionize. They partially form what? Hydroxide. I mean hydrogen ion. So weak acid partially what? Partially ionize. And examples you need to know about acids which produces which are weak. We can talk of ethanoic acids. We can talk of carbonic acid. I was talking about this acid, and we are talking it to be unstable acid very soon. And another acid, it's phosphoric acid. So this kind of acid partially what? Partially ionize. Now, strong acid, it's the opposite. They completely what? They completely ionize. An example, it's where we have hydrochloric acid here. We have hydrogen bromide. It is strong. We also have hydrogen iodide. So this acid what? They completely ionize to form what? Hydrogen what? Hydrogen ion. See the only positive what? Charged ion. Let's now we talk about weak and strong bases. What about weak and strong bases? So it is the same. Weak bases, they partially ionize. Okay, weak bases partially ionize, and examples of weak bases. I was talking about ammonium water. I was talking about ammonia. It's a weak what? It is a weak base. Also magnesium hydroxide. It's a what? It's a weak base. We talk of magnesium hydroxide. So these are weak bases. For them to form what? They form what? This hydroxide ion what? Partially. They cannot form it completely because they what? They partially ionize. Now strong bases do what? They completely what? They completely ionize. Examples are calcium hydroxide, also barium hydroxide. So these are what? They are what? The noise is disturbing me somewhere. Sodium hydroxide. After sodium hydroxide is written as this. So let's try to look about some other things before we conclude, because we are concluding. So in an exam you may be asked this kind of a question. What is the net ionic equation when a hydrochloric acid reacts with sodium hydroxide? So since you already know that the reaction between an acid and a base produces what? Salt. And so what you do, you're going to say hydrochloric acid, which is in aqueous, plus sodium hydroxide. Sodium hydroxide also in aqueous will produce salt, which is sodium chloride. This sodium chloride is the salt which is going to be produced, and water, liquid state. So what we are going to do now, is now to balance the equation. So as we can see here, hydrogen we have 1, 2, even here we have 2, so the equation is balanced. So what we just do is to write the ionic equation, splitting the ions for the compound which are in aqueous. So here we are going to have hydrogen in aqueous plus chlorine ion in aqueous, sodium ion in aqueous, hydroxide ion in aqueous. To the product side we have sodium, okay, sodium ion, it is also in aqueous, chloride ion in aqueous. Then water, we know that water is in liquid, so we leave it like that. Else we cancel now spectator ions which are found on both sides, to imply that they are not participating in what? In the reaction. So we are going to cancel this. We'll go with this and this one with this. So what remains is hydrogen ion plus hydroxide. plus hydroxide ion to produce what? Water. So this is what? The net ionic equation. So this is all about lecture 3 family. So if you find this video helpful, please consider subscribing. Also, you hit the notification button, you like the video, so that it may reach to other audience. So if you missed the previous lectures, lecture 1 and lecture 2, you need to go to the channel, or I'll post the link in the description so that you may watch also. You also need to share this video so that it may reach other people. See you in the next lecture.